Hello, and in this video we're just going to finish up the graphing transformations of logarithmic functions. The first two videos talked about basic graphs and some transformations, right, left, up, and down. This one's going to talk about reflections. So remember, we switched the x and y from an exponential to find the graph of a logarithmic function. There are two types of reflections. There's a horizontal or x-axis reflection. That's when the negative happens in front of the logarithm, and when we put the negative inside the logarithm, it reflects on the y-axis or vertically. So our normal logarithm would be, let's see if we had an example of f of x equals log base 2 to the x. Alright, so basically we would graph the exponential function to the x and then switch the values around for the logarithm. So -3, -2, -1, 0, 1, 2, 3. This would be 1, 2, 4, 8. And 1/2, 1/4, 1/8 here. So when we swap them around here, my graph is going to look like 1/8. So okay, so we're going to just graph the inverse. All right, so 1/8, -3. Be really close to the axis here. 1/4, -2, still really close to the axis. 1/2, and then -1, it's about halfway there. 0, 1, 2, 1, 4, 2. So this is my f of x function, which is this graph right here. Now if I were just to change this by putting a negative sign in front of it, then all that would happen here is the graph would reflect on the x-axis here. So it would be, this would still be here at that point, this point would be up here, and then we'd go this way, and this one would reflect here, and this one would reflect down here. So this would be the graph of g of x, the negative in front of it. Same base, same points, but they're reflected. So instead of 2, 1, we go 2, -1. Okay, we reflect them. Okay, and then if we did the last type of reflection, or review the last type of reflection here, if we took the function and put a negative sign inside, like this, then we would reflect this blue graph across the y-axis. So this point would reflect to here. This point is 2 out, would reflect to 2 out here. This point is 4 out, it would reflect to 4 out here. That's 4, -4. These points would reflect, here's half, here's a quarter, here's an eighth. So we would get this graph right here. This would be h of x. That's a reflection. Now, in the order of graphing, okay, you would first of all shift right. So when we're doing this graphing methods, and there's several things that happen, we want to shift right or left first. So the first thing would be a shift right or left. Then we would reflect. If you needed to, then you would stretch or compress vertically. And then after that we shift up or down. Okay, so this is the order that you would go in finding this. Now, if I gave you an example of something that did all of these things, like a function that had this as its equation, then we would say the first thing that would happen here would be a shift horizontally left 1 from this part right here. That's the first thing that would happen. Second thing would happen would be a reflection on x-axis. That would be a horizontal reflection. The next thing would be a vertical stretch by a factor of 2. And then the last thing here would we would shift down 4 units. So this would be the order I would do something that looks like this. The graph would look like this purple graph because it would be reflected on the, it would look like the green graph, sorry. Green graph because it's reflected on the x-axis. It would be the green graph, but that one would be shifted down and stretched out, so it would be taller here. Instead of being here, it would be twice as tall up here. We'd stretch that out first. This stretch would be away from the x-axis. So we stretch away from the x-axis. So those are the last parts of transformations of logarithmic functions.